Hey everyone! Today we are going to look at a solution to one of my favorite graph theory problems, chat screenshots, from Codeforces round 925. For those of you unfamiliar with Codeforces, it's a website for competitive programmers with challenging algorithmic and mathematical problems. Let's have a look at the problem. We're told that there are n people in a group chat. Out of these n people, k people post screenshots of their fellow texters' names with their name being at the top of the list. We want to find out if these names are sorted in a particular order that is consistent with the screenshots. For example, the names could be sorted in alphabetical order. Then each person would see all names with their own ordered lexicographically. Of course, in this case, we don't know what the ordering is. I like this problem because it is not immediately obvious how we can use graph theory to solve it. Let's look at a sample test case where people are represented by numbers. Now, we can't actually derive any information about the ordering from the position of the first person, since the first person is always the screenshot taker. However, the next bits actually do give us information. We know that in whatever ordering we have, 2 comes before 3 and 3 comes before 4. Let's use a directed graph to represent this information. We can do this by, say, letting an edge going from U to V mean that U comes before V in our ordering. Alright, something you might immediately notice is that this graph is acyclic. This means that a topological sort of its vertices exists. This is great because we have just found out one possible ordering of the vertices. 2 appears before 3, which appears before 1, which appears before 4 being one of them. The reason this works relies on the very definition of a topological sort. Remember, a topological sort is defined as a reordering of the vertices of a graph such that it is only possible for a node with a smaller index to have an edge to a node with a larger index and not the other way around. Since an edge existing between two nodes U and V means that U comes before V in the ordering, the topological sort exactly corresponds to a possible reordering that will work. However, a topological sort may not exist in all cases. Consider this graph. Here, we want 1 to occur before 2 and 2 to occur before 3. This means that 1 must occur before 3. But an edge from 3 to 1 also exists, so 3 must also occur before 1. This is impossible, so we have no topological sort. If we build this graph from some input, that input must have been inconsistent. So we have a straightforward solution. Build a directed graph from our input using the aforementioned rules and check if it contains a directed cycle. If so, then the screenshots correspond to no particular order, otherwise they do. Finding a directed cycle in a graph is pretty simple. We start from an arbitrary vertex, say 1, and perform a DFS marking nodes in the current path as green and other nodes we visited as red. If we run into a green node twice, we've found a cycle.